Hi all, I am K. Surya working as Assistant Professor in the Department of ECE at SNS College of Technology. So the next topic in this video lecture series is co-channel interference. So co-channel interference is very important in all the cellular networks. So it is related to the capacity of a network. So whenever the interference is less, the capacity of the network can be increased. So we will see about what is co-channel interference and how to calculate the co-channel interference and what are all the methods to overcome this co-channel interference. So interference is a major limiting factor which affects the capacity of the cellular systems or say the performance of the cellular systems. So it creates a bottleneck in increasing the capacity. So interference in there are two types of interferences, either in voice channel or control channel. So an example for interference in voice channel is crosstalk, and an interference in control channel is a blocked or missed calls. In general, when compared to rural and urban areas, the interference will be more in urban areas than in rural areas. So the reason behind this is that because of greater RF noise floor and more number of mobile phones. So there are several sources from which this interference is caused. So which are say another mobile which is used inside the same cell using the same frequency, or a call in progress in the neighboring cell, other base stations which is operating in the same frequency band, or non-cellular systems which leaks energy into the cellular frequency band. So these are all the reasons which causes the interference in cellular networks. There are mainly two major types of interferences, which is co-channel interference and adjacent channel interference. So in this presentation, we will see about co-channel interference, and we will go with the adjacent channel interference in the next presentation. So before going into co-channel interference, we need to know what is co-channel cells. So you know that when several sets use the same set of frequencies is known as frequency reuse. So all these cells which use the same set of frequencies are known as co-channel cells, and the interference which is caused because of these cells are known as co-channel interference. So this co-channel interference cannot be controlled by increasing the RF power. So because this will increase the co-channel interference. So in order to reduce the co-channel interference, one main important method is that you have to maintain a minimum distance between the co-channel cells that uses the same frequency. When the size of the cell is approximately the same, then the co-channel interference will be independent of the transmitted power. So one important factor which we need to know here is the co-channel reuse ratio, which is denoted by capital Q, and it is given by capital D by capital R. Here capital D is nothing but the distance to the center of the nearest co-channel cell, and capital R is the radius of the cell. So Q is equal to D by R. So whenever this ratio Q is increased, then the interference will be reduced. So this is a diagram which represents the co-channel cells. Here the yellow cells which uses the same set of frequencies. So this all this cell 1 will create an interference. So in general, for one particular cell, normally more interference will be caused from the first tier of co-channel cells. So generally here it is 6. So for an hexagonal geometry, you can also represent that Q is equal to root of 3n. So Q value should be optimized here. So where smaller value of Q will provide larger capacity, but the interference will be more. Whereas large value of Q will provide less interference, but it will affect the transmission quality. A trade-off should be made between these two objectives. So as shown in the tabular column, So as the size of the cluster increases, then your co-channel reuse ratio also increases. So one method to overcome this co-channel interference is to vary the cluster size. So you have to choose a proper cluster size such that it does not affect the capacity, and also it does not affect the quality, and also less interference is maintained. So you know that n is calculated using I square plus ij plus j square. So value of I and j is used to calculate the cluster size n, which we have seen already in the frequency reuse. So let I naught denotes the number of co-channel interfering cells. So as I said, normally the first tier of cells will cause more interference, where I naught will be equal to 6. So now let us see how to calculate the signal to interference ratio. So which is given by S by summation of I is equal to 1 to I naught II. So S represents the desired signal power, and I is the interference power caused by the ith interfering co-channel cells base station, where N is the path loss component which varies between 2 and 4. So average power received can be calculated using this expression, where PR is equal to P naught into D by D naught the whole power minus N. So N is the path loss component, D is the distance, and D naught is the distance of the antenna from the closing reference point. So in terms of dBm, it is shown here. So when the transmission power of each base station is equal, then your signal to interference ratio is modified as R power minus n divided by summation of I is equal to 1 to I naught di power minus n, where R is the radius and E is the distance as said already. Now if you consider only the first tier of interfering cells, so this can be written as root of 3n the whole power n divided by I naught, where I naught will be equal to 6. So in this diagram, you can see the 6 interfering co-channel cells. So these 6 cells marked as A represents the co-channel cells in the first tier. So it's an example where AMS requires that the signal to interference ratio should be greater than 18 dB. So for this condition, your N value should be 7 for a path loss component of 4. So your cluster size here should be equal to 7. So this is a case of signal to interference, which is the worst case. So in general, you'll be placing the antennas at the center of the cell, whereas here antenna is placed at the cell boundary. So when it is placed at the center, the distance with other co-channel cells will be the same. But in this case, since it's placed at the boundary, the distance varies between the adjacent co-channel cells. So as shown in this diagram, so distance between these two cells is d minus r. Distance from the center cell to the this cell is d, and here it is d plus r by 2, d plus r, and d minus r by 2. So based on this differences in the distance, your signal to interference ratio is calculated using this formula, where r power minus 4 divided by 2 times d minus r, then d minus r by 2, d plus r by 2, D plus R, and D. So that's all about co-channel interference. Hope you understand what is co-channel interference and how to overcome it. Let us take few assessment questions. What are co-channel cells? Cells having different base stations, cells using different frequencies, cells using adjacent frequency, cells using the same frequency. Yes, as you know, cells using the same frequency are known as co-channel cells. Co-channel interference is a function of A. Radius of the cell, B. Transmitted power, C. Received power, and D. Frequency of the mobile user. So co-channel interference is a function of radius of the cell. So it's equal to D. You know, co-channel reuse ratio is Q is equal to D by R. Okay, so that is your next question. Co-channel reuse ratio is given by Q is equal to D by R, where D is the distance and R is the radius. Thank you for watching this video.